So today we are going to learn the basics of programming, as well as we are going to go over the entire overview of Python. This is the session 1, and yesterday's session in which we installed Anaconda and also learned the basics of Jupyter. That was the installation session, and that we are calling as session 0. Today's session is why should we learn programming, basic understanding of hardware architecture, then Python as a language, and then getting started with Python. Okay, so this Python course is for absolute beginners, but it will soon become a little advanced. So stay tuned. We're going to start with very basics. So you'll have to have a little patience with the people who are learning new. Then we will go into the details, and the course is very focused on hands-on. That's why we conducted session 0, in which we learned the installation. Some of you have requested for recap of yesterday's session, so I'll just go over yesterday's session and then we will go into the details. All right, now this is the agenda for today's session. Today's session is agenda is why program, how does hardware architecture looks like, how is Python as a language, and we're going to go over the entire basics of Python in a single shot for those who are really hurrying up, and then we will go step by into each part. Okay, so before that, before jumping into this, some of you have asked me for um, going over yesterday's session, and what we discussed yesterday was 2 plus 3. Okay, so yesterday the agenda was that we should be able to write our very simple code 2 plus 3. 2 plus 3 is 5. We all know that, but this could be the most simple course. All right. So the easiest way of getting to the hands-on is you can use CloudX Lab. We built CloudX Lab so that you don't have to install anything on your machine, and it's very easy. Once you take the subscription, you should be able to see the login password and then click on Jupyter. Okay, so I'm going to share with you this is the link, so you can sign up for the CloudX Lab, and there you will quickly get the entire environment. And once you get the environment, you can simply click on Jupyter. All right, so here we go. If you click on my lab, when you go to this lab page, you can go down and enroll now. Okay, and once you have enrolled, you will see in the lab credentials these details. And when you click on Jupyter, you will get the folder structure. This is your folder structure where all of your data or the programs will be kept. Okay, so once you log in into Jupyter, you will see this kind of a folder structure where for you it's going to be empty because you may not have created the folders. For me, because since I've been working here for quite some time, therefore I have a lot of folders and files accumulated, and you can upload the files and folders from your home directory. We'll discuss about these parts later. Let's go into the Python 3 console. We are going to use Python 3 as part of the course. Okay, this is Jupyter. Okay, this is Jupyter. Jupyter is nothing but a browser-based interface for Python interactively. I'll show you. So this is where this is called a cell. In the cell, what you do is you type your code. Okay, so you can see that we have typed 2 plus 3 and the value is 5. Okay, and how do you execute? After typing the code, press shift and enter. Press shift and enter and you will get the result. Okay, also you can see that whatever we do in the previous step, like here we are setting the value of x is a variable to which we can set any kind of value, and here we are setting the value of x is 5. If we go into the next cell and say x, then we will be able to see the value of x is 5. This is the absolute beginning of the Python language. So we are going to talk about these parts later. For now, in the Jupyter, you can use it as a calculator. And let's say I'm able to use it like a calculator and press shift and enter. All right. Great. So which file? You don't need to open a file. You can just click on new and click on Python and it will open. Okay, I'll show you again. So once you go to my lab, you'll see Jupyter, and under Jupyter you will see when you click on Jupyter, you will get this kind of interface. And when you click on new and click on Python 3, this interface will show up. And this is where you write your code. All right, you press, once you're done, you press shift and enter. All right, so this is a very quick overview of how to get started. Okay, this is the overview of how to get started. All right, now right, now you can also log in into the console. Sometimes you prefer to work with the console, not with the Jupyter. In that case, you can just go to the web console, and here when you click on, you might have to provide login password. I'm just showing you at CloudX Lab. So you get a full-fledged web console. This is where you can actually do all kinds of work. Okay, it's a proper Unix system with all the available libraries for machine learning. And in order to start Python 3, what you have to do is you have to export the path, to this, and then activate and then run Python 3. All right, let me just give you the command. All right, let me just try again. Yeah, this is the right way. There is supposed to be a space, but all right. So what you see is that we should be able to log into Python 3. In case you get into this prompt, you can type this 3. You can see that it has worked fine. And this you can use it like a usual calculator. To exit the prompt, what you have to do is press Control and D. Okay, you have to press. For that matter, in Unix, everything exits at Control D. Control D represents end of the input. Great. Now, this is the console. And now let me go over if you are trying to install by yourself. So we have provided CloudX Labs so that you don't have to do much of installation. But if still you would like to go ahead with your own installation, you can simply download Anaconda, prefer the Python 3.6 version. And once you have downloaded, you can just search for Anaconda and click on download. This is the screen that will come up. And once you're done with that, you can click on Anaconda Navigator from the start menu. And after that, you can click on Jupyter Launch. And there you will be able to see the Jupyter screen. All right. So similar Jupyter screen will come up the way I had shown you. And using Anaconda prompt, you will be able to launch the Python 3. Also, to access your course, whosoever is signed up with CloudX Lab, whether free or paid, you'll be able to see your courses under My Courses, and there you can start learning. All right, this was a quick recap of yesterday's session about installation and getting started. So to know more about us, visit CloudX Lab. To have discussions, you can go to cloudxlab.discuss.cloudxlab.com. And for more questions, you can send emails. All right, now we are getting back to, all right, so let's start our journey with the programming. All right, so first question that almost everybody asks me is, why should I program? And the answer is generally something which Steve Jobs once said, that everybody should learn how to program a computer because it teaches you how to think. All right. I do agree with these words, and I find that when people are able to solve their problems more efficiently if they know how to program. They're able to work out stepwise solutions, as well as they are less confused about computing. What computing can do, cannot do, what looks like hoax news or real news, as well as once you know programming, you will be able to avoid the chores by automating it. So I was reading about somebody, and they had to do a lot of pre-production work in the video. And what What he was doing is he had to create like 20, 30 folders before every recording starts. And once he learned programming, he was able to automate those chores. And there are many other reasons why you should program. One of them is it teaches you how to structure your thoughts. It teaches you that the best form of learning is being able to program. If you are learning something, unless you can program it, you haven't learned it really. Okay, so basically, it's a very important skill in today's world to program. Almost everything that you do is one way or another impacted by programming. So I was talking to a few of my friends in manufacturing and how the cement factory and how he was able to control the temperature automatically using a small bit of program, something that was really, really harsh on really, really hard work, as in a person has to be 24 by 7 up and keep controlling the valve in order to control the temperature in a cement factory. So almost every way today the manufacturing is turned into a basically computing environment. You build the designs using computing, and then those designs are actually built. Similarly, even the people who are in hardware, who are building like the machines, the physical robots, or any kind of machine, the entire system is actually computing. All right. So this is something that has happened. The people who are in networking, for example, they have the whole system has become programming and computing. And similar is the case of DevOps and all of the ecosystem. Everywhere, the since we are able to emulate, debug, and stepwise go into details, therefore, almost every engineering or every science is impacted or is being done via computing. All right. So there is almost so it's very important to learn programming. All right. This is the little bit motivation I wanted to give you before we start, because that's always a question that I'm not an engineer, I'm not going to build this or that. Why should I learn programming? Right. Also, today you use so many apps on the mobile phone, and for almost everything, there is a mobile app, and therefore, you could also build your mobile app use if you learn programming. All right. So computers want to be helpful. Computers are built for purpose to do things for us. But we need to speak to the computers by the way of a programming language to describe what needs to be done. All right. So we keep on telling computer that what to do next, what to do next, and we need to describe that part. And that's what is computing about. That's what is programming about. So programmers anticipate needs. We as engineers, we take a case of say iPhone application market. There are so many apps. There are applications over 3 billion downloads in total, and programmers have left their full-time job in order to build the iPhone apps. So programmers anticipate needs. Okay, and the best way to anticipate need is to solve your own problem, and that the chances are there are many other people who are going to need the same thing. Now, users versus programmers is not a big difference, but users see computers as a set of tools like word processors, spreadsheet, map, to-do list, etc. And the programmers learn the computer's way and the computer's language, right? So programmers have some tools that allow them to build new tools, and programmers sometimes build tools for many users, and sometimes programmers just write these little script for helping themselves or helping other people to automate some tasks. right? So some programs could be highly used by many people, some could be used by just you, and that's completely okay. In all possible ways, we are trying to automate and avoid labor in repetition. So from software creators' point of view, the we build the software, the end users, the stakeholders or actors are sometimes we look at them as masters. It could be anybody, it could be a kid, or it could be somebody who we want to please or who we would like to solve the problems for. Often they pay money and when they're pleased and so, but the data, information, and networks are our problem to solve on their behalf. All right. Sometimes we tend to avoid this part, but it's very important. So, as a software engineer or programmer, we need to learn these parts. We need to learn the networks. We need to learn the data. We need to understand how to deal with information and how to deal with the computers. All right. And so hardware and softwares are our friends and allies in this conquest. All right. Again, why be a programmer? To get some tasks done in very simple words, to produce something for others, right? And what is code? Software or a program? The code is basically, a software is basically built of code. A program is again the sequence of instruction. So sometimes we call code, sometimes we call it a software, sometimes we call it a program. At the end of the day, all of it is nothing but a sequence of stored instructions, a sequence of instructions. It's a little piece of our intelligence in the computers. It's a reflection of our intelligence in the computers. It is a little piece of our intelligence we can give to others. So we build a recipe or a program and we give it to others. And it's a piece of creative art. All right, those who are absolute beginners, for them, the program could look like the instructions from your dance instructor, and they could look like when the music starts playing, left hand out and up, right hand out and up, and so on. So the programs for you could look like this, or you can think of programs like instructions for a recipe. All right, great. Now moving ahead, but for when you start programming the computers, you will realize that the life is very interesting, or you can say goes crazy. The 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 say for example, the life would look like this. The the clown ran after the car, and the car ran into the tent, and the tent fell down on the clown and the car. So so basically, when you start programming, you will realize that a lot of things are not exactly like a dance step. All right. Those who are looking for how does a code look like in Python, this is what it is. Okay, so this is a very simple word count program. What is word count program? What does word count program do? It reads the text from a file and then counts the unique words that are there in that text. Okay, so this is an example of Python code. Do not worry, we are going to learn everything again from basics. This is for those who are looking for looking for a glimpse in Python. Okay, and it's a good idea to actually start from the code itself. All right, I'm going to go over this piece of code quickly and then work on it. All right, so it's a little old code. All right, so I'm going to, let's say, paste it here. So it's asking for the file name, but we don't have a file name. So I'll just go and see if I can provide it a file name. Don't worry if you don't get it right now. So, all right, let me just take the a.txt. All right, a.txt, a.txt. or big.txt. There should be a file called big.txt. All right. Now, where did it go? I'm just going to copy paste the entire thing. All right. So we have already done this part. We have taken the name. Is there a big.txt somewhere here? Oh, it's not. Okay, I'll just use the another one. Shift enter is what it brings. I'm going to show you, don't worry and panic, because we are going to deal with it again. So this line read the file from us, and then this one is going to open that file, then read the text, and then going to split the words. Okay. Now let me check what does words look like. You can see that words look like this, and then this part is going to going to all right, it says that missing parenthesis, don't worry, and here we go. Okay. All right, let me just change it a bit. This is the code in. Oh, let me, okay, this is good enough. All right. Okay, so you can see that the name has occurred 5 times and so on. All right, so biggest word in this is the name, which has occurred 5 times. All right, great. So this is an example of the code. Those who are running it with me, I'm going to give you the code. All right. Let me see if I can give you here. Like, there's no quick way of sharing the code because this thing is not allowing me to share everything by itself. Okay. Don't worry, we're going to share it with you. All right. Actually, when I'm trying to share the code here, it's losing the formatting as well as it's losing the, it's not letting me copy paste this much. Okay, so what I can do is, okay, one of my teammates will copy and give you the access to the code using some public tool. Okay. All right. All right. So one of my teammates will basically give copy paste this code to one of the public the copy bins, paste bin actually, and give you the link. Okay, that'll be easier. All right, so this is how the Python code looks like. This is how Python code looks like. Here it reads the data, here it finds the frequencies, and then here it finds the biggest word, the most frequent word. That's what it is doing here. Okay. Now, so you can see that there is a loop here. These are the assignments and so on. We're going to go into more details as we go forward. All right. Now back to the basics. Back to the basics. Let's talk about hardware. We're going to go really fast over the hardware architecture because most of you have already known about these parts. Okay, now, all right, so this is what the microcontroller or the processor looks like. Okay, at the heart of the computer, this is what it is. There is a processing unit, there is a processor, and there is something called a main memory. This is something called a main memory, and there is something called a secondary memory, sometimes referred as a disk. And then there are input and output devices, the screen and the keyboard and everything. Okay, the main memory is the RAM. We call it RAM, random access memory, and sometimes we just refer to it as memory. The The secondary memory is for permanent storage, and we read data back and forth from here. While the heart of the system is CPU, Central Processing Unit. It's a small chip. It's a small chip by Intel or by AMD or by Qualcomm. And what it does is it reads the instructions from the memory and then take an action. Whether it can update back the memory or it can talk to any of these devices as well as it can talk to the secondary memories. Okay, so this is how the generic computer look like. All right, all right. Any questions at this point? All right, great, great. Moving ahead. So So this is what we talked about, a CPU. It runs the program. The CPU is always wondering what to do next. Okay. And it's actually not a brain, but it's very dumb, but does things really, really fast. It reads the instruction from the RAM and does next thing. And doing next thing means reading data from somewhere or executing next instructions. So those are the things that CPU does. Then there are input devices like keyboard, mouse, and touch screens. And output devices could be screens, speakers, printers, or DVD burners. And the main memory is basically RAM. But if you restart your computer, the main memory is reset to empty. Okay. Therefore, you have secondary memories. It is slower but permanent. Okay. Unless you delete something, things stay in the storage even if you reboot your computer. All right. So this is where the instruction is kept. If x is less than 3, print something. This is a simple instruction, and CPU will pick up this kind of instruction and do the work. Okay, and this instruction is kept in the binary or the machine language. All right, so and once since the CPU does a lot of work like this, it consumes energy and it heats up. Okay, and this is a hard disk which is a permanent storage in which you keep your movies and you keep everything. This is the hard disk. This is how the hard disk looks like. It has a header which basically moves on the hard disk on the disk. It's like the tapes that you have heard of earlier. So this rotates here in this YouTube video. You can watch that. I'll just share this with all of you, and you can know about this is the an example of our CPU, and this is hard disk in action. Great. So basically, this is something that you should keep in mind. Okay, a lot of work goes into shuffling data here and there. You will be writing your program, which will be converted into the machine language. You'll be writing this kind of code, which will be converted into machine learning, would be into machine language, would be kept in the main memory, and CPU will read instructions from here and do the work. Okay, so this is how it would look like, and by the way of instructions, you will read data from input devices and secondary memories. All right, it wouldn't look this hard when we start working. Okay, so for you, the code is English. You will be writing the code in the English language, and it'll be very, very simple and easy to retain. Okay, so coming back to Python as a language. So far we have talked about basic systems, and Python is the language of the Python interpreter. So we write the Python code. Python interpreter understands it and execute it. Why interpreter? Because it goes step by step and runs it. Okay, it does not compile the whole code and into something else and then run it. Instead, Python interpreter goes string by string and executes your instructions. Okay, so it's an interpreter, not it doesn't have a compiler as such, though there are compilers built at Python which make Python execution really fast. We'll talk about the Python compilers later. So Python is a language of Python interpreter which you write, and it was developed by Guido van Rossum, and it's quite popular language. I'll talk about. We need to learn this language so that we can communicate our instructions to Python. And when we make mistakes, instead of saying cute, it will say syntax error. All right. And the computer assumes that you are intelligent and you can learn, you can write your code correctly. And remember that you will be able to learn entire thing without having to worry. All right. Now, going back, let me answer a few general questions that would keep on coming again and again. One is, why do people use Python? Python has all the features of a language that can be used for building good software. And when we say good software, or when we define software quality, it means your code, your program should have a good readability. If you have a good readability in your code, it'll be reusable and maintainable. Trust me, your code which you write once in a company is read by at least 50 times. At least 50 times, no matter how useless the code is. Okay, and the software quality is the other feature that defines your software quality is object oriented and functional. We will see these keywords later on. We will try to address and go into the details. What does it mean by object oriented? What does it mean by functional? And the second reason why people use Python is developer productivity. Since we don't have to type just too much, there is a less work required. And hence, if you have short code, it's less to type, it's easier to maintain, and it's clearer to debug. All right. And third is program portability. If I write my program on my Mac, it will run very well on Windows, and so on. And the libraries that are provided in Python are all kinds of libraries. You can do almost everything with Python. Okay, you can have a text matching library. You have a text matching library, and you have machine learning, you have network scripting, and the website construction, numeric programming, serial port access, game development, and so on. Okay, now just to let you know that CloudX Lab, the whole web application as well as the lab, entire thing is maintained and built using Python. The reason was exactly these things. You could do almost everything using Python. Also, you can have a great integration with other libraries, and Python actually brought joy to me. Here I'm making a personal statement. So I have been writing programs in Java and other languages for more than 15 years. And whenever somebody asks me to do something, the first language that I pick up is Python. Though I have, out of all the languages that I've learned, the Python is probably the least number of years I've worked. Only last 3 years is what I've worked on Python. Okay, but I find it most easier and easier to learn. Last time when I was teaching people Java as a complementary course as part of my big data, I found that it was really difficult to teach Java anybody who's beginning the career. Also, what I found is because of the complex programming languages in which you have to type too much, when you have to type too much, there is a mental block. There's a mental block of typing, and hence programming is supposed to give joy to people while it becomes chore, and that's an important part. So that's one of the reasons why we have picked up Python, and that's why the a lot of people have picked up Python is because you don't have to write too much of code to get things done. The code is very easier to read and very easier to look at, and therefore this course or learning Python would make the programming enjoyable again for you. Okay, and yes, for a lot of people, programming becomes a pain, as in when they think about programming, what they think about is there'll be a lot of typing and so on, right? And that therefore the joy is not there, right? So this is one of the reasons you must learn Python, because one, it's really easy, and second, it's the most popular language. You can do anything with the language with it. Wonderful. Other question that I very frequently face is that, is it a scripting language? Yes, it's a general purpose programming language that blends procedural, functional, and object-oriented paradigm. We will go into more details as we go ahead into these. What are the downsides? It is slightly slower than C or C++, but you can always compile it with the new generation compilers, and those compilers make it faster. All right. So if you are really right, and trust me, if you are building a website or a program, the execution speed of your code because of the language matters hardly 5%. Hardly 5%. Okay. And that one is basically very well done, solved by either compiling or by doing a load balancing and so on. Okay, so execution speed, though, that seems to be the issue with many people, but in my life, I have not seen one case so far where the execution speed mattered so much. And at the points where it mattered, those were only smaller pieces of programs that I could write and hand it over in C and call from Python. Okay, so you can always write in another language and then call it from Python, and that's the general strategy people follow. All right. Now, who is using Python? Google, Netflix, the biggest software engineering companies are using Python. Okay, and ourselves also. CloudX Lab also, the entire system is built using Python. You can read about success stories here. There are many applications, there are many user codes, and the Wikipedia page for Python. The another question that I face is what can I do with Python? Python is general purpose. You can develop web applications. You can handle DevOps. DevOps is when you're taking care of the systems automatically, and the automation in your organization, entire thing can be done easily in Python. Python is easier and is a preferred choice of deep learning. Oh, sorry, I kind of missed this part. So what I can do with Python is, sorry, what can I do with Python is I can do systems programming, right? The assessment systems which we have built is based on Python. The web application which we have built is based on Python. And you can build GUIs, graphical interfaces. You can do the internet scripting, and you can do component integration, database programming, rapid prototyping, and numeric scientific programming, as well as machine learning, and gaming, images, data mining, and so on. All right. So that's the reason why Python is a choice for R, not for ML. And because because one should learn a programming language which can be used and is easier to begin with. Okay. So these are our reasons for using Python instead of R for this course. Okay. One, Python, if you learn Python, it will not be only applicable to ML, machine learning, but it'll be a general purpose. So, and Python is easier, and Python is preferred choice for even deep learning courses. All right. So that's why TensorFlow was made available first in Python, then in R. All right. So basically, again, one more thing I would like to say here is that 95% of the job of a data scientist, of anybody who is playing with the data, is 90% of the time is goes into data cleaning, data formatting, data extracting, and that task is actually biggest work. While applying a machine learning algorithm it would take hardly 5% of your time in a typical industrial problem. The main time would go in data cleaning, and this is where Python would come really handy. All right. So who is behind Python? One is Python Software Foundation, PyCon, and Python Enhancement Proposal. There's a group. All right. Okay. So we've already done this part. You'll have to provide your login password if you are logging in Jupyter, and once we are there, we will be able to log in. All right. Okay. So you can start working with Python using the console here. I'm going to show you briefly. Okay, so here you can start working with console and start working. This I have already shown you before, and this is the Jupyter. All right, great. So, all right, so I hope that you are able to start with Jupyter. Are you able to get to this screen? Whether using the CloudX Lab or you're using your own installation, you should be able to reach the Jupyter. Jupyter is an environment where we will be writing the code instead of using the classical IDEs. We are going to interactively code. Interactively code means instead of writing the full file of code and saving it and running it, we are going to run the code stepwise. All right. This is how the code looks like interactively. And all right, now let me show you. If I say here print X, not like this. We have to say like this. Okay. So we could say hello world. So this is another example of the first code that people write. Great. I'm assuming that you are able to log in and have it. All right. So let's start with the basics of Python as a language. Let's start with the basics of Python as a language. So the elements of Python are basically the words, sentences, and the story. Words, sentence, and story. Okay, this is how you can look at the words. When we call them words, it is nothing but variables or reserved words. Okay, variables or reserved words. When I say sentence, sentence is an expression. Okay, so the variable of words is x, 2, 5, 3, or maybe a string like hello world, right? Those are words. Sentence is the valid expression. When I say print hello world, that's a sentence. When I say 2 plus 3, that's another sentence. Okay, and story is a full-fledged program that you can save on the disk and run it. Okay, we're going to go with all of these parts. Okay, so again, this is the short story about counting the words. This is the short story about counting the words. Okay, and the words, when we say words, you are not supposed to use some of these words because they carry a different meaning. These are called reserved keywords or reserved words. Basically, and, del, for, is, these are the words that carry the the that carry special meaning in Python. Okay, so this one you see x equals 2 is an assignment statement, and x equals x plus 2 means that the value of x will be added by 2 and will be assigned to x. Okay, and print statement means printing those words. Okay, so I'm going to take you through this. I'm going to make a few corrections here or there because this is some of it is in Python too. All right, so what does it mean? I'll show you. Okay, so this is probably the easiest next statement. I'll actually just keep switching between the two. Okay, so when I say x equals to 2, see x equals to 2, I'm assigning 2 to x. All right, so you see the value of x has become 2. If I say x equals to x plus 2, the value of x is how much? 4, right? And if I keep on executing this statement, and let me say that I'm saying print x here, what would happen is the value of x will keep on increasing by 2. All right? So this is how the assignment works. So you see, so first we assigned value 2 to x, then we assigned x to x plus 2. This is the previous value, and the new value of x will become this. Okay, clear to everyone? All right, so my request to all of you would be, instead of sitting back and just listening to me, work with me, open your Jupyter and do whatever I'm trying to do. All right, okay, so try executing this. All right, try executing this in Jupyter. All right, I'm assuming that you have done it. A question is, what is the scope of X? X is available to the whole program. Okay, scope of X means what the variable we are defining here, where all is it available? Available, it is available in this worksheet all over, as in wherever you want to use it. We'll talk about scope in terms of blocks and the curly brackets, the way we learned it. So that's what we're going to learn. All right. Don't worry about the scope. Good question. What if we assign something like a string to it, right? That's one of the questions. It is happily able to accept the string. So it will basically override the integer with string. All right. I think if you experiment with these variables a little, you'll be able to uh, get the idea of what goes inside. Now, if I say x plus 2, it's going to throw an error. It's going to say that it should be string, not integer. You see that? And to do this, if you want to append it, you will have to convert it into a string. Okay? All right. So whenever we are learning programming, please keep in mind that you will have to do a lot of. All right. A question from Ujala is: so does Python need the conversion rules during programming? Yes, it does. So we'll have to keep on casting the variable or converting the variable by ourselves. Okay. Are there classes in Python? Yes. If are variables accessible across classes like Java? You can. Yes. Okay. We'll talk about that part as we go ahead. All right. Great. Now is the time that we move ahead with data types and other parts. Good. All right. So Python scripts are interactive Python. The way we are right now doing the program is by the way of creating interacting directly, right? I'm going to show you something like a script. Instead of reading through this, I'll just show you. All right. So whatever we did here, what if we wrote a program? And how do you write a program? You go to say here itself, and we call it text file. Okay. We are just writing a text file in which we are saying x equals to 2, or let's say x equals to 10, and this is what we are writing. All right. And here we are saying that we're changing the name by clicking on the file name, and we are saying hello Python .py. Okay, this is any name you would like to keep, it's up to you. Or we can call it simple. Okay, now this is saved in my home directory. Now I can go to my console and exit from here. This is the Unix console. Those who are not comfortable with this, you can skip it altogether. So here, this is the console, and this is where almost everything is done. Whatever I would like to do, usually in Unix, this is where I will pass the command. This is basically waiting for me to type the command so that it can give the results. And the commands that I type here are Unix commands. Say, for example, the first Unix command is ls to list the files. Okay. First Unix command is ls. For Windows, it could be dir. Okay, and there I can simply say Python 3. Okay, and space. What's the name? What was the name of the file? Simple exp.python, and it did not give any result. Why? Let me take a look. Or did it? No, it gave. It was not saved earlier. Right. So you can see that the value it has printed 12 as the value. Great. So this is the way you can write a proper program, not only the interactive way in Jupyter or the console. You can you using the Python console, you can do the interactive programming, but using this Python 3 command line way, you can execute any program this way. So when you're building a bigger software, you will be preferring this way. When you are doing the data analysis where you want to inspect the data frequently, you will be using either the Jupyter or Python interactive shell. Good. How can we simulate this in Windows? You can basically write in the notepad and then save it. And once done, you can do the same commands as Python 3 and launch. A question from Akshita is that It's not an ideal program, but if we declare a lot of variables, so on in one session, how does memory handle it? So basically, the newer variables, if they are of the same name, they will override the older ones. Is that the question you have? And if we declare a lot of variables, they are going to definitely consume the memory. And we're going to, yes, the probably one other doubt you would be having is with respect to the scope, right? That what if we don't want to override it and so on. For that, we will go into the details about the blocks, the scope of a variable, right? Another question is from Rahul Pal. Question is, so what are the data types in Python, or are the variables in Python like those in JavaScript wherein the variable depends on initialization? All right. So yes, just like JavaScript, the variable type depends on initialization. The data type of a variable is is inferred from the initial value, and rest of the operations on a variable, just like x here, the rest of the operations depend upon the initial value. So if you have defined x equals to 2, then x plus 2 is a valid work, right? But if you have defined x equals to Rahul, then what will happen is it will throw an exception. A follow-up question from Akshata is, what about performance when we are defining so many variables? So performance, basically, those are the things that we will have to work upon in order to avoid declaring just too many variables at one point. So declaring too many variables or declaring something as an array would not impact too much of performance, but there are ways we can make it more performant. All right. So as we go ahead, we will learn that part. A question from Noor is that do we have to run program by Anaconda prompt or Windows command? I think Windows command should work. I could try with Anaconda prompt. Try Anaconda prompt and then try Python 3 there. It should work. All right. A question from Rohit is, are there classes in Python? Yes, there are. We will talk about this, and I've answered this question. Okay, good. Great set of questions. Keep the questions coming. All right. Now, so far we talked about interactive as well as script. In the interactive, you can use the Jupyter console, Jupyter notebooks. And for script, we can save the file the way I showed you and execute the script. So like a recipe or installation instructions or dance steps, a program is a sequence of steps that are to be done in certain order. Some steps are conditional, meaning if you already have this, then don't do this, right? Some steps are conditional. Some of the steps, when we are doing things like an installation or a recipe, we might have to keep doing it, keep repeating. For example, keep on stirring it, right? And those steps are repeated. Sometimes we store a set of steps to be used over and over as needed several places throughout the program. For example, while in the recipe, we would just simply say boil the egg, right? That's kind of something to be reused over and over again. So this is what is a program. Program is like a recipe, and installation instruction um, is basically sequence of commands and sequence of steps, and every step could be either do something or could be like a condition. If there is this situation, then do this. All right. And sometimes the step is repeated. Sometimes we store steps separately and then reuse them. So we'll learn all these aspects. So the sequential step is, we've learned that the in Python, the flow is top down. So if we here the these are the these the se- this is the sequence in which the program is executed. First, x equals to 2, then print x, then x equals to x plus 2. So whatever we define the previous step is meaningful in the next step. Okay, and if let's say we skip this part and simply said x equals to x plus 2, then it will throw an error. I'll show you. Let's say we are we are using another variable. Let me keep it open. Okay, so we could define things like, let's say we start using x equals to y plus 3, And in the next step, we are defining y equals to 3. It is going to throw an error. It's going to throw an error that y is not yet defined. Okay, y is not yet defined. So why? Because if this statement could have been before this, it will work fine, right? It'll work fine. All right, good. Now these are the conditional steps. This is how the conditional steps look like. Say, for example, we are assigning 5 to x, and then we are saying if x is less than 10, print smaller. If x is greater than 20, print bigger. At the end of it, print finish. All right, let me show you this part. I'll have to make some corrections here or there. So this is my simple program. I'm going to show you. Okay. So what will it print? Yes, everybody? It's becoming hard to share things. Why don't I start maybe Google Doc? Okay. I think I should just give you access to Google Doc. Okay, let me try creating something. But this one will actually I will text sharing. I'll just give you this. It's a good way of sharing with everyone. I'll just say, okay, so here we go. I think I'll just keep on pasting my code here. Right? Yeah. Okay, so yeah, we will share the slides from next session onwards with all of you. Okay, great. Now let's move ahead and do this using Jupyter. Okay, we have not here, not here. I'll just close it. It's going to print. It's going to print. Okay, it is has replaced these with something that you can have. Yeah, you see this code. This is an interesting thing that happened. You see this code that is here. Let me increase the size. You see, this code is basically not a single code. It's a strange backcode, and be aware of these kind of codes while programming because they become a big problem. So you can see it has printed smaller followed by finish, right? I'll update the collab edit. Okay, good. All right, so what happened here? We set value of x to 5. What does it mean? X would be there somewhere in the memory and we have set its value to 5. Okay, and then we are checking if x is lesser than 10, meaning we're comparing 5 and 10, right? And which is true, right? This statement is true. That means if some statement is true here, we do the print. All right. Then if x is greater than 20, then we print bigger. All right. And here we are saying print finish. So I hope everybody got it. Anybody wants me to repeat or explain in more details? Yes, you're right, Partha and Giji. All right. Yes. One important part to notice is thank you, Rohit, to bring that point. Yes. In case of Python, the way it recognizes that this whole thing is under if condition is by the way of detecting the the indentation. Okay. Yes. So indentation means that this print statement belongs to the previous statement. If we do not provide this indentation, it's going to throw error. Is expected an indented block. All of these have to be smaller. Python is case sensitive, therefore P has to be smaller. Right, Archana? It is case sensitive, so P should be small. Also, um, there is a confusion about Python 2 and Python 3. The biggest difference is that in case of print statement, in Python 2, brackets were not required, but in Python 3, the brackets are required. Further question from Pradeep is, how do you recommend we indent? Using spaces of how many or tab? It's up to you. If you are creating programs, it's an important question that while you're creating programs in an organization, there's a full project that you're working on. It's better you indent using 4 tabs. Okay, but here using Python, using Jupyter, it's easier to just use tab. Okay, so here in case of Jupyter, we're going to stick with tab, while in the usual editor, you could use 4 spaces instead of tab. And Python is completely okay with it. Yes, 4 spaces. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's also possible, but we will stick to a tab because that's correct way of dealing with it. All right, that's correct way to deal with it. So just use tab instead of space. Question from Sumit is it right to use 2 if statement? Yes, definitely. It's completely okay to use 2 if statements. Okay. A question from Srikanth is, will it work if one uses 8 spaces and other uses 4 spaces in the same project? No. So if in the same file you're using somebody using 4 and somebody using 2, it's going to throw an error. Generally, the way it detects is based on the first indentation. Okay. So right now I gave only two spaces. That also worked fine. All right. All right. The ideal way is to stick to a uh, same indentation throughout the system. If somebody is using 2 space for single indentation, just use 2 spaces. If somebody is using 4, then use 4 in the whole project. Okay. Do not change. Great. All right. So yes, as a practice, I think that seems to work. In even if you have different set of spaces, it seems to work with Python. But my suggestion would be to stay consistent with respect to indentation. The purpose of indentation, there is a lot of programmers find it very strange to see the indentation as part of the syntax, while all other languages allow as many spaces as possible. But in case of Python, the indentation is part of syntax, because the biggest challenge in every programming is code need to be maintained and code should be readable. And one problem that is solved by using Python is the Python enforces indentation. That means your code is going to be very much readable. Also, it has reduced 2 extra symbols like curly brackets, and therefore it becomes really, really easy to read somebody's code. Okay. So suggestion would be to use 4 spaces if you are building a project, and if you're working in Jupyter, just stick to the tab. Okay, because in case of if you're using some other text editor, you can set those text editor like Sublime or some other. You can use those text editor on your local machine and happily you write Python code, and the tab can automatically be substituted by spaces in those editors. You can set the tab equals 4 spaces. So the text editor itself will replace tab with a text editor with a tab with 4 spaces. Okay, so I can show you. All right, great. Now moving ahead. Right, I think it's time for break. All right, so I'm back. Should we start now? Great, great. So far what we have learned is the basic steps in Python. I hope this conditional step was kind of clear, but even if it is not, do not worry, do not panic. We're going to address it in more details at later point of time. It is kind of um, a crash course right now. We are just getting into the various statements so that if you are if you know these parts, you can start you know working with Python. All right, instead of very slow going mm, into every minute detail right away. If you just take a code and start experimenting with this piece of code, then what will happen is you will be able to tweak it, and by the time you finish tweaking it, you will get the fair amount of idea. And as I said earlier, that the only way to learn is by asking questions, by questioning things, and by trying yourself. Okay, great. So there are a few questions that I would like to answer before I move ahead. One of the questions is, why are we using Python 3, not 2.7? Python 3 is kind of well supported, as well as Python 3 is something that everybody is going for. Okay, and we went through this dilemma whether to go with Python 2.7 or Python 3. Then when we looked at the entire scenario, it made sense to learn Python 3 instead of learning Python 2. Okay, the the main difference is probably in one of the print statements and divisions. Those are the main differences which I see. Other than that, everything looks okay. There are very minor differences, probably three or four visible differences, and those are good enough for. I mean, those are something that can be managed. Say, for example, in Python 2, the print statement looked like this, while in Python 3, the print statement looks like this. Okay. Also, I'm going to show you something else. Um, I'm going to show you the. If you divide it 2 by 3 in Python 3, you get 0.667, right? But let me show you an example with, does the Python 2 work here? I will just go on my laptop. I have only Python 2. So here you see, when I say Python here, it shows me Python 2, right? Let me increase the font. You see, it's Python 2. When you type here, say 2 by 3, it's 0, not 0.66. There, so this was another difference. First one was with respect to the print statement. Print statement. In Python 3, the print statement is like this. Okay, Python 3, the print statement is like this. Okay, and in Python 2, both works, this as well as this. In Python 3, this has been removed. Okay, then there are very minor differences. Those are basically bug fixing, and you will get more picture as we work forward. All right, now going back to where we were. So this was the answer to the question whether why we are going with Python 3 and Python 2 and what are the differences. And there is one more question that I can see. Okay. So a question from Noor is, so Python is used only at backend on the server like ASP.NET. So Python is used in both. I mean, yes, browser generally understands the HTML, CSS, and JavaScript. So Python is not used in the browser, but Python is used to build the front end, such as the thick clients you can build with Python. And with Python, you could build the backends of the system. That's true. And with Python, you could build all kinds of automation script. Okay. A question from Juhi is that how can you call this file with extension .py on Anaconda browser? So what you can do is there is, I think run is supported. Somebody in the session was saying that you could actually call using run inside here, and the file name was simple exp.py, right? Just open it because it's not working, kind of. Simple exp.py. I hope it works. Yes, it does. Okay, this is another way you can call the. All right, thank you, Ujala. A question from Gangaram is, for me, live stream is not good. Is there any way to download offline or save the video? Okay, we will. You can actually, there are YouTube downloaders using which you can download it later. We will send it to you. All right, great. So, all right. Now, the next step is, okay. So, okay. So a question from Juhi is that how can we run this from the command line? You can actually go to the command line like the way I've gone and say Python 3 and run it. This should work fine. If you are on Windows, you might have to say Python only and then run it. You can open the command prompt and then run it. The only thing you have to make sure is that Python should be in your path. All right. So on Mac, let me answer this question. On Mac, have you installed Anaconda browser and Anaconda locally? Let me try showing that. I think this is something I missed earlier. Okay, so you can open Anaconda Navigator. Okay, it's taking some time to initialize. I hope it doesn't crash anything. I'm kind of very used to using the CloudX Lab uh, uh, subscription. Okay, so here we have, I think, Navigator, Jupyter Lab, Jupyter Notebook. Okay, all right. So I think the console, you can launch it from here. Just let me exit from here. Okay, so yeah, let me exit from here. It doesn't make sense right now. All right, for me, if I launch it, I go to the console here. I'm able to run Python. Okay, and can call the program from here. You can say Python and space and say the command line. All right. Also, you can open the Anaconda prompt from the launcher. There's an application called Terminal. Using that, you can do. All right. Great. Now moving ahead, and point from Aziz that if you are trying to learn ML before you have a full grasp on underlying language, in this case Python, you are probably doing wrong. Okay, so yes, so basically I would say that you get a good hang of the language, only then we move to the machine learning. Otherwise, what you will end up doing is you will end up memorizing the set of algorithms and memorizing how to call them instead of really learning programming. And trust me, machine learning is more about programming than just calling random algorithms. All right. The only stable way of learning any machine learning or any algorithm would be to take a look at the underlying algorithm and try to at least implement one of those. That will kind of make you think in terms of those algorithms. All right. Great. All right. I hope Juhi, you got the answer. And I hope Aziz, yeah, thank you, Aziz. You're supporting my view. Okay, coming back to the next step, sometimes we might need to repeat the steps. Okay, just like in the cooking, we might say keep stirring it or keep doing it for these many times. So similarly, in the programming, we would need repeated steps, and repeated steps are the easiest way of repeated steps is this. So here we are saying keep doing it, keep doing these things till the point n is greater than 0. Okay, so we are saying n is 5, this number is 5, and we are saying till the point n is greater than 0, keep printing. And every time we are decreasing n. And then finally, we say blast off. Okay, so again, here we have to convert this into the Python 3. It's very simple to convert Python 2's code to Python 3, just like this. Okay, so don't worry, even if you are feeling that you don't get it's not working correctly. Okay, don't worry, even if you don't get everything in more details, you will learn as we go. Okay, so here again the dashes has become wrong, not works. All right, now I'll give you the code here and this will be better. Okay, please keep in mind when we copy paste things from here and there, the dash becomes some strange characters, don't remain the ASCII dash, as well as quotes, single quotes, double quotes, both become strange. So generally when you're copy pasting from the PPT or Google Docs or Microsoft Office, make sure your quotes are fixed correctly. Good. Is everybody okay? So n was 5 earlier, and then the loop started. Since n is greater than 0, it goes ahead and then printing 5. Then n is decreased, then control comes back here, and now n is 4, which is greater than 0, and it prints here. And then 4 becomes less than, 4, the n becomes less than 4, which is 3. Now the 3 is greater than 0, and then prints 3, and then it becomes 2, which is greater than 0, then it prints 2, then it becomes 1, and then it becomes 0, and which is 0 is not greater than 0. Okay, so try experimenting with it. So if you say 50, it should print 50 times. Okay, and if you decrease it by 2 at every step, you see it starts giving us even numbers. All right, and if you divide it every time by 2, it becomes interesting. See, it never reaches the end. It keeps on going, but after this point only, it becomes negative. It becomes kind of 0. All right, so you can see that you can do slight variation and experiment what happens where. Okay, or let me say greater than 1, for example. You see, 50, 25, 20, 12.5, and 6.25, and so on. Okay, so you can experiment with this, and you can try writing your logic with this. Okay, again, while followed by a condition, as long as this condition is true, it will run everything which is indented after this. Okay, colon is what is required here, and you should be able to do that. Great. All right, so yes, is everybody able to execute this inside the Jupyter? Great, wonderful. All right, so this was the beginning of the loops. We will go over all of these concepts as we go further, and you will get better idea. Okay, if you want me to explain these again, it's very simple. It's like the algorithm chart. N equals to 5, then if there is a conditional statement which says if n is greater than 0, go this side. If n is lesser than 0 or equal to 0, go this side. And if yes, then print n. And then here we are decreasing n by 1, and then going back here, checking again, and doing that. That's what is happening here. All right. Okay, so these are sequential steps. Then this is repeated step here, and then here you see the conditional step. We'll go into more details about each of these. All right. Our question is, how do we comment something? What is comment? Those. Thank you for asking that question, Ravi. Answering that question, and let me just try to answer this. So generally what happens is when we are writing code, something which we would like to inform our some reader or for our own notes, we would generally like to write comments. Comments could be anything. Comments are something that is not a part of language. Okay, that means that comment can be anything, whether in English or French or any other language. So comment could be anything. And here, this is an example of comment. Okay, so it has no effect at all. If a line is beginning with a hash, it has no effect at all. All right, great. So Shrudi's question is the joined just now. The difference between machine learning and AI, a general question. What is real in today? Today, we are not going into machine learning and AI. Today, we are learning Python. So far, what we have learned is the basic construct of a Python program. And then we are going to go go into the more details about Python. All right. So the next 3 sessions, we are not going to touch upon machine learning or AI, but after 3 sessions, we will talk about machine learning and AI. All right. All right. Another question is how to copy and paste within Jupyter Cell. You can easily copy paste. You can use your normal browser shortcut. See, I've just copied this code and pasting it here. You see, you can use normal browser way of copy pasting, right? All right. Great. Now moving ahead and okay. All right. So this is how the program looks like, and we have gone over it now. All right. So what did we learn today? We learn so far is that how to get started with Python, how to write the simple statement, and we will go into more details now. So we'll focus on the bigger picture after this. All right. So let me. A question from Rahul: is using triple quotes the right way to include multi-line comments? Okay. So yeah. So triple quotes is basically for defining the multi-line text. Okay. For defining the multi-line text, though you can definitely put the triple line quotes in order to write any kind of string inside your code. Okay, great. Now, so again, we are going back to the basics. So far, we just gave you an overview of how does the Python program looks like. Now, the first and foremost thing in any programming language is constants. Constants are numbers or strings. For example, a constant could be 123, constant could be 98.6, or constant could be a string. A string in Python could be surrounded by single quote or double quote. Let me show you this part. Okay, so let me just show you how does the strings look like. Okay, so we can either say 1, 2, 3, 4. This is a normal constant. This is a number. This is a number. While if you put a decimal after it, it becomes not here. It becomes a decimal number. This is how you define decimal number. And of course, we can put minus before it to make it a negative number. Also, the we can write the strings like this by using double quotes. What is a string? A string is an array of characters, or a string is kind of a name, or it's kind of set of characters. All right. So a string could be defined using double quotes, or it could be defined using single quote. All right. Also, if your string includes single quote, then double quotes can contain single quote, as well as single quote could contain a double quote. All right. I'll show you. What does it mean? Let me show you. So this could be single quote, and if your actual word contains the double quote, you can surround it with single quote. Okay, does it make sense to you now? All right. So we can also, in case, let's say you would like to put double quotes within double quotes, you put a slash before it. Okay, it's called quoting the character, or what do you call it? It's called escaping the character. So you see that? Since we wanted double quote in our actual string, and if we just put it like this, what would happen is it'll be ending the string, and therefore it would not work. So you can put slash before it, right? Or you could put either single quotes around it or double quotes around it. So single quoted string could contain double quote as such, while double quote single quote string can contain double quote as such, and double quoted string can contain a single quote. All right, great. And in case you would like to print slash in the output, what you have to do is, let's say you want to print slash in the output, what you have to do is this. See, slash double quote. So first slash is escaping. These two slashes are getting converted to one slash, and this slash and double quote is getting converted into double quote. Okay, it makes sense to you? This is something I found that many people are generally confused about, so I thought I'll give you an explanation. All right, regarding the execution of the code, I'm not going to go into those details right now. All right, right, because we have already done the execution of this part. All right, so the next concept, though we have already gone through many things, we are going back into the details. A variable is a named place in the memory where a programmer can store data and later retrieve that data using the variable's name. The programmers get to choose the names of their variables up to whatever they like to, and the programmers can change the content of a variable in a later statement. Okay, so So for example, if we are saying x equals to 12.2, there is a memory space in the system where 12.2 is kept, and x is the name given to that memory space. And similarly, y is the name given to 14. 14 is kept in memory somewhere. If I say here in the third statement after this, if I say x equals 100, what does it mean? What does it mean? It means that we are going to update the location of x with a new value. Earlier it contained 12.2, now it contains 100. The rules with respect to the Python variable, you can keep any name, as long as the name starts with a letter or an underscore. And also the first letter can only be the letter or the underscore, while rest of the letters can be numbers or underscore. Space cannot come in the variable name. Okay, so the good example of Python variable name is spam eggs spam 23 underscore speed, while the bad example is 23 spam because it is starting with numbers, so it is an invalid variable name. Okay, and hash sign, so hash is anyway comment, so this will not be accepted. Similarly, var.12, it is an invalid variable name. It totally changes the entire meaning. Okay, so and also the Python variable names are case sensitive. What does it mean? It means that spam and capital S spam or capital spam are three different variables. Okay, you can give it a try. If I try to say define a variable 23 spam and 23 spam and say try to assign it, it gives an error, right? And if I put even things like this, it doesn't matter because it gives an error because it's expecting as this to be a variable and this is something else. Okay, while this is perfectly okay. This is perfectly okay. All right, so our question is there a special meaning of double underscore? Basically those are kind of conventions. Okay, double underscores are kind of conventions. It for using it like internal variable or something like that. Okay, we'll talk about it in a while. Okay, S- so but this is also a valid variable. You can see we just defined a variable with two underscores. All right, so variable names, this is how we can define the name of various variables. Also, you cannot use any of these words as variable names. Okay, if you try to define things like and equals 3, it will give an error. Similarly, if I say dal equals 3, it'll give an error, right? So we cannot define, we do not define our variable using any of these words. Okay, you'll get familiar with it. All right, thank you, Cool GDU, for answering that question. All right, and all right, this we have already talked about. The sentences or lines: x equals to 2, x equals x plus 2, and so on. Right. Now, when there is a difference between assigning and comparing, this is one big difference which I found in found when I did not know programming. So x equals to 2 does not mean that we are comparing x and 2. We are saying put 2 at a place where put 2 as a value in x. Okay. Now we assign a value to a variable using the assignment statement, like equals. An assignment statement consists of an expression on the right hand side and a variable to store on the left hand side. Okay, so here you can see that there is quite complex expression on the right hand side. This is an expression, and the value will be computed, and then the computed value will be kept on the left hand side. Okay, the computed value will be kept in the left hand side. So whatever is the previous value of x will be multiplied by 3.9, and then the result will be multiplied with 1 minus value of x. Okay, so this way you will get some value here that will be assigned to x. These are called assignment statements. Okay, so imagine that the value of x was 0.6. So 0.6, the value of x will become 0.6 here, the value of x will be 0.6 here, and then 1 minus 0.6 is 0.4, and then 3.9 multiplied by 0.6, and then multiplied by 0.4. The result is this. This is going to be saved at this place. Okay, this is going to be the value of x, which means that we are going to update the memory with 0.93. Is it clear to everybody? Yes? All right, great, wonderful. Wonderful to have a great set of candidates in the class. I can see that a lot of you are already answering each of this question. Great. So basically, the equals statement is the assignment operation. Whatever is the value of the right-hand side will be computed and assigned to a value x. All right. Also, Binto, we will talk about the classes and the variables in as we go ahead. Okay. So all of those parts, what Cool GDU is trying to explain, we will talk about it in the session in details. All right. Great. So basically, what we learned just now is the assignment operations. And assignment operation is nothing but whatever is the value of expression will be computed. Here, what we are doing is we are saying x equals 3.9 into x into 1.x, right? So what will happen is the value of x being zero point 0.6 will be substituted in the whole expression. So it'll be 3.9 into zero point 0.6 into 1 minus zero point 0.6. So 1 minus zero point 0.6 is 0.4, and that will be um, multiplied with 6.6 and then multiplied with 3.9, and the result will be 0.936, right? And this value is going to be updated here. Okay, if this computes to 0.93 or 0.936, that is what going to be saved here. You want to give it a try? I'll show you. So if we have this here, x equals 0 0.6, and we are saying this. So the value of x is 0.936. You can see so many nines. This is approximation. All right, it's essentially 0.936. All right. So the three constants that we have talked about so far is integer, numeric, as in the decimal number, and strings. Okay. All right. So here, these are the various operators supported on numeric numbers. All right, on numbers. So plus is for addition, minus is for subtraction, and asterisk is for multiplication, while the slash is for division, and while asterisk is for power, and percentage is for remainder. Okay, and there is one more thing that's not there, which is two slashes. Okay, we'll talk about this. So if you want to divide 2 by 3, that's okay. And if you want to put exponent on this, okay, so we can say 2 to the power 3, which means this is equivalent of 2 into 2 into 2. Okay, and remainder is something that we should know. If let's say we want to find out what will be the remainder if we divide 4 by 3, so what will be the remainder? It will be 1. Okay, and the same will be, let's say, 14 percentage 3. What does it mean? When we divide 14 by 3, the remainder is okay. So I hope that's clear to you. Okay, so when we say remainder, it's basically this. We are dividing something, let's say 23 percentage 5 or 23 modulo. Percentage is also called modulo sometime, which means we want to find out the remainder. Okay, all right. Yes, thank you, Juhi, for reminding me that. Okay, so I was talking about double slash. Let's say you want to do integer division. What is integer division? Integer division is that the decimal parts are deleted. Say, for example, when we divide 2 by 3, the answer is zero point 0.6. But if we are just looking for the integer part of it, we could say 2 by 3 like this. 2 double slash 3. Okay, what it means is the decimal part will disappear. So 5 divided by 3 will be 1. Right? And 5 divided by 3, the integer division, you can see the decimal part is gone. All right. So double slash is basically a operator to divide to do the integer division. Good. That's correct. That's correct, Murthy. That the remainder will be lost and only the quotient will come in the general maths terms. Yes. So earlier in Python 2, if you divided something like 5 by 3, this is what used to happen. I'll show you. If this is my Python 2, and here, if the normal division used to behave like integer division, if we had to divide things properly, we had to translate them to decimal number and then divide. Okay, great. The other important aspect that you will learn is the order of evaluation. When we have many operations in operators in a expression, Python must know which one to evaluate first, which one to do first, right? We learned BODMAS and those kind of rules earlier to do the expression computation. In the same way, Python also follows similar precedence in order of precedence in case of operators. So, so you can see that here this looks like a really complex one. You see 1 plus 2 into 3 minus 4 divided by 5 to the power 6. So question is which one will get evaluated first? Yes, it'll be 5 into 6, 5 to the power 6. Okay, so here are the rules. Here are the rules. The most important ones, the first one that get evaluated are something in the parenthesis. Parenthesis is the highest precedence. Then the exponentiation, which is raising to the power. Then multiplication, division, and the remainder. Okay, and then addition or subtraction. And once these, if we have, let's say, addition or subtraction same over and over again, then the order of evaluation is left to right. Okay, left to right. And of course, the last one to be evaluated is the assignment operator. Okay, the last one to be operated is the last one to be evaluated is the assignment operator, right? Because the value of x will be set only after the entire expression is done, right? So let me see if I can show you right away. Let me show you these things right away, and here we go. So you see, this will be computed first, and what would that be? Let me just open another. You see, this will be computed first, and then the division will happen. Okay, so again, let's go with it. All right. So this is what is going to happen. So parenthesis followed by power, then followed by multiplication, division, and remainder as in modulo, and then addition and subtraction, then left to right. All right. So this is what it is going to do. So this diagram shows you that 1 plus 2 to the power 3. So this will be computed first. So it will become 1 plus 8 divided by 4 into 5. Then 8 by 4 will convert into 2. Then 2 into 5 will convert into 10. And then addition will happen. And then, of course, assignment will happen. Okay. So parenthesis, here there is no parenthesis. And, and okay, parenthesis, power, multiplication, addition, and then left to right. Okay. All right. The important part is that the at any point of time, if you are getting confused about operator precedence, use parenthesis. Also, keep the mathematical expressions simple enough that they are easy to understand. Break long series of mathematical operations to make them more clear. Okay, so all right. The similar thing would happen further as we go ahead when we talk about Boolean operators. Similar operation precedents will occur there. Again, the same rule apply that try to keep them very simple. Instead of trying to stuff all the expressions in a single shot, you break them down into separate expressions. Right. So Python, this is what used to happen in Python 2. In Python 2, if you divide 10 by 2, it'll be 5. It'll divide 9 by 2, it'll be 4, and so on. It used to happen that way. But in case of Python 3, the whole thing changes. All right. Earlier, this used to be a problem when we used to divide things and mix integer and floats, but this problem is now solved in Python 3. Okay, in Python 2, if you this will result in 0. So the only way to correct things was to put dot 0 with them to make them explicitly float as in decimal number, and only then things will work properly. Okay, so in Python, the variables, literals, and constants all have a type, all have a data type. Python knows the difference between an integer number and a string. If you try to add two numbers, it will happily accept them. Similarly, it will basically compute it to be 5, while if you try to add two strings, it will concatenate them. But if you try to concatenate one string and other number, what will happen is it will throw error. Okay, so the variables in Python have types. Okay, I'll show you this. This will make more sense to you. I'll show you. So if I say 1 plus 2, right? So the value of x is 3, right? If I say x equals single quote 1 plus single quote 2, right? The value of x is 12. So here a string plus another string leads to concatenation. The meaning of plus had changed because of the data type of the underlying value. A question from MVVR is that, is Python a OOP or functional programming language? I would say it's both. Okay, Python is both. It has all the concepts of OOPs as well as functional programming language. Okay, I hope this is clear to you. The meaning of okay. So this is the difference between data types. Okay, so Python knows the difference between integer number, and a string or a float. For example, plus means addition if something is a number, and concatenate if something is a string. So plus means something else based on the data types. Okay, a question from Juhi is that what is the difference between print x and x? Okay, so on the interactive shell, we can simply say a variable name and it would display the value of that. You don't have to really type x. Internally, it's doing print for you. Good, good question. All right, now we must know the data types of our variable because otherwise, it would lead to wrong results. The way 1 plus 2 became 12 just now, in the similar way, many other errors could occur. Okay, so the types of variable in Python is one is integer, second is the decimal number, they call it float, but we don't have to define them explicitly. The initial value of a variable, the initial value of a variable dictates the actual value. We can definitely convert the one data type to another. I'll show you as we go further. So other example of other example about why we should know the data type of a variable is that if you try to concatenate a string with, so for example, if we have here x is 12 and let's say y is 5, right? If we say x plus y, what will happen? It's saying that must be string, not int. Why? Because x is 12, which is string. You see the double quotes? That means x is a string, while y is a number. You cannot concatenate the two. Also, to explicitly find out what is the type of something, we can say type and then x. You see, the type of x is string, while type of y is int. And if I say type of 4.3, it is float. These are basic three data types that we have talked about so far. All right. So you can find the data type of anything using the type function. A question from Krishna is, what if I want to print the result of colon, add a number stored in a variable with a number? Okay, so if you want to really, okay, I think I got your question. Thank you. Um, what if I want to actually do this? So there will be two ways, but let's say there are x plus y is what I want to do. One, we convert y to string, okay? Convert y to string, that means 5 will be concatenated to 12 and it will become 1 to 5, okay? The other way is we could convert this into integer and add y to it, right? X was 12, now it's 17. But if you add a float with a number, what will happen? With a float with integer, the result will be a float. Okay? A question from Bintao is that how many data types are in Python? These are three. We'll talk about more as we go ahead. Don't worry about all the data types. And what's the difference between data type and data structure? Data type is the basic data types. Data type is the type of data, and data structure is a bunch of variables combined together. Okay? Data structure is bunch of variables combined together in order to solve a particular problem. It's called data structure. Data example of data structure is map, hash map, array, and so on. We'll talk about these as we go ahead slowly. All right. So we have talked about the different types of numbers. One are integer, other are floating points. There are other number types. They are variations on float and integers. Okay. So also we can do the conversions explicitly. We can put an integer and floating point in an expression. The integer is implicitly converted into float, right? The way we just added a number with a float, the integer automatically got converted into a float. We can also explicitly convert the data types using the functions like int and float. So the way I was trying to demonstrate here that we converted x into integer, we can also convert a float into integer, right? So if I convert float into integer, the decimal part will be removed. Okay. And if I convert integer into float, it will remain as such, just that 0 will be added at the end. Okay. Does that answer your question, Gangadharam? Okay. Also, when we operate on two variables like int and float, int is generally converted implicitly into a float. All right. You can control this with built-in functions. We can also use int and float conversions to convert between strings and floats or strings and int. If you are trying to convert something into integer and that is not a valid integer, you will get an error. Say, for example, I'm trying to convert this. It says that SA132 is an invalid string, invalid literal for int with base 10. All right. So you have to basically, this, whatever you're converting into integer, it should be a valid number. Okay. So Dino's question is that what's wrong with this program, right? So temp is E, that's right, here, which is string, correct? And then we are saying, you're saying that we convert that into here. Let me just delete this part. So you can see that invalid literal for E because E is not a valid number, right? Great. Moving ahead. So basically, you will get an error if you are trying to convert or parse the string into numbers. Okay. All right. User input is important. We can instruct Python to pause and read input from the user using input function. So here we are saying input e name equals input, who are you? And then we are printing that. All right. So we could also write this simple program. We could say input, who are you? And we are taking it in this. So it's asking for my name. So I'm just writing my name. And when I say name, it has my name in it. And then I can say happily welcome. And right now I'm going to just concatenate it. Right? Here, this string gets concatenated and then printed. Good. All right. We'll talk about types of errors at the later point. All right. Gangadharam, I would like to know which part are you confused with. So here what we are doing is we are reading the value inputted by the user and then using that value. Okay. We can also, to concatenate strings in print, we could just put comma as well. Okay. All right. So we can also convert the user input into a number. Okay. Say for example, we could say here, we could say Europe floor, and then we convert that into a number, and then add it to 1 and print. Okay. So here, if we say Europe floor equals input. Okay, and it's asking for Europe floor, and we are saying 3, and then we are saying here we are saying print 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 US floor, and we are saying we are converting it into integer and adding it to 1. So it's asking for this, and see, we're just printing something greater than 1. All right. Okay, so I'm going to just paste it here. Easier to do. I'll figure out if I can share my worksheet with you. Okay, great. So we'll talk about how to deal with bad input later point of time. We'll talk about error handling and debugging. Okay. All right. So with respect to comments, anything after the first character hash is ignored in Python. Okay. Even though the hash does not need to be the first character, you could also have hash like this. And here, this is a valid command. So let's say we are writing here, take input. This is the command. This is a valid command, right? So generally, we use command to describe what's going to happen in a sequence of code, document who wrote the code or other ancillary information, turn off a line perhaps temporarily. Okay, say let's say you want to turn off a particular line for some time so that it doesn't get executed. Just comment it out. Just put comment hash in the beginning. Most of the editors, text editors, provide you a way to quickly comment, while in case of Jupyter you might have to put the comment by yourself. There's no shortcut key. All right, so that's pretty much for today. We will continue from here in the next week. All right, I look forward to see you on the discussion forum. For questions, come over to the discussion forum, discuss.cloudxlab.com, and keep asking questions. That's the only way to learn. Bye bye. Have a great day.